welcome back to the Math 116 class. Today we're going to cover section 12.1. We're going to cover angles and different type of angles. So like I've said in all my videos, you can always stop, pause, you can always come back to them and review as many times as you need. Okay, so just by looking at the first four of these angles, we recognize some of them. Now, right angles. Right angles, they have that little window for the 90-degree. And right angles, we also call them 90-degree angles. An acute angle looks something like this. And notice it is less than 90 degrees. So this is going to be less than 90 degrees. So we're talking about it can be 1, it can be 10, it can be 30. Obtuse angle is going to be classified. It's going to be more than 90 and less than 180. Because if it's 180, it's a straight line. Sometimes you'll see it written like this. Now, adjacent angles are two angles that share one side. So what I mean by this is if you have an angle we want to say it's A, B, C, and D. And you've got right here angles 1 and angle 2. It means that angle 1 and angle 2 are adjacent. And they share side AC. And with a side, you can put like a little line on top of it. Okay, perpendicular. Think of an intersection. You can also think about if you've ever had graphing in school, think of graphs. Okay, what they do is they actually form, look at this, 1 right angle, 2 right angles, 3 right angles, 4 right angles. Okay, angles that complement each other are complementary angles. Okay, the key word to this is 90 degrees. In other words, that means angle 1 and angle 2 has to equal 90 degrees. A quick little example would be, say if angle 1 was, say, 40, what is angle 2? All you'd have to do is subtract 40 from 90 and you get this to be 50. Okay, angles that supplement each other, I want you all to think of that to be 180. So 180 is a straight line. Let's say if you have an angle right here and maybe it's 60 degrees, what would this angle be? And maybe we call that angle A. So angle A would be what? Well, you would take 180, subtract 60, and you'd get 120. Okay. Like I said before, please at any time pause it and come back to any of these examples. Okay, vertical angles. Okay, when you think of vertical, I want you to think about a cross. Okay, so if you think about a cross, so what I want you to do is that we want to pair these up. So what are vertical angle of angle 1? Well, vertical angle of angle 1 is right across from angle 1 is angle 3, and angle, say, 4 is angle 2. So a quick example could be if angle 1 is 60 degrees, what is angle 2, angle 3, angle 4? Well, the vertical angles are always, if they're paired up, they're the same. So 1 is paired up with 3. So that means 3 is also 60. That means that since vertical lines are the same, that means the other pair had to be supplement of the other angles. So all you would have to do is take right over here 180, subtract 60, and you get 120 on 2. And since 2 is paired up with 4 for vertical angles, it's also 120. Now, the next is transversal lines. So transversal line cuts through 1 and 2. So it intersects two or more parallel lines. So 1 and 2 have to be parallel. Okay, the orange line is a transversal line. 1 and 2 are parallel lines. So that's what a transversal does. Now on my next pair of terms, I'm going to use this transversal line to demonstrate how to predict what angles are. So I want to kind of, let's see, I've got interior angles and exterior angles. Okay. Now, interior angles means what angles are inside the two parallel lines, and exterior means what are on the outside. Well, let's look at the interior. Look at this, 3, 4, 5, and 6. So I'd say angles 3, and look at my angle symbols. And look at my exterior. That leaves 1, 2, 7, and 8. And I just put this in numerical order. I mean, you don't have to, but I just did that. Put it in numerical order. Now, I want to use the same one. I've squeezed it in to use what corresponding angles are, alternate interior and alternative exterior angles. So when you think of corresponding angles, you want to think of angles that are on the same side of the T or the transversal. Okay, so let's look at 1. What looks like 1? Okay, it's on the same side. Does 3 look like 1? Does 5 to 7? Well, 1 and 5 are the same. Okay, now look at 3. 3 and 7 are the same. Look at 2. 2 and 6 are the same. And finally, 4 and 8 are the same. Same side of the transversal line. Okay? Alternate interior. That means, think of, in a way, it's a cross in a way. So take a look at 3. What angle looks like 3? Well, across from 3 is 6. And you also have 4, and across from that is 5. They're the same angle. So whatever 3 is, 6 will be. Whatever 4 will be, 5 will be. What about all the alternative exterior? Okay, so let's look at 1. 1 and what? 1 and 8. And also look at 2. 2 and 7. Okay, now finally I want to have one other example, and this kind of gives us more examples for corresponding in the different alternative exterior and interior angles. So here's what I'm asking us. I'm giving you this line. And maybe, so there's my transversal. I'll just go ahead and label it. Say this is my transversal. This is my X and my Y. And my X and Y are parallel with each other. So corresponding. So my corresponding, I'm going to look at 2. What corresponds with 2? It's on the same side of the transversal. It would be 1. What about 6? 6 and 5. What about 4? 4 and 3. And finally, 8 and 7. Now, the alternative interior means if I look at that 6, what is across from 6? The 3. What about the 1? It's the 8. And finally, the that could also be this is the alternate exterior. Okay? So this would be, what about 2? 2 across from 2 on the outside would be 7. And finally, 4 and 5. Okay, for those that are in my Math 116 class, we're going to have homework number 5 on WebAssign. Okay, once again, thank you for listening. And my next video that is related to this will be 12.3, 12.2, which we're dealing with polygons and quadrilaterals. Thank you very much.